Somewhere in the pitch-black understory of a forest, a mouse takes a single breath. No moonlight, no motion, no sound louder than a heartbeat. And yet, 6 feet away, something is already tracking it. Not with eyes, not with ears, but with a sense humans don't even have a name for in our own bodies. That something is a snake, and what it's using isn't magic. It's a pair of tiny holes on its face that can detect heat so precisely they can sense a temperature change smaller than 0.003 of a degree Celsius. To put that in perspective, that's like standing in a stadium and feeling one specific person, 40 rows away, exhale. So how does an animal build a heat camera into its own skull? And why, after millions of years of evolution, did humans never develop anything close to it? Stick around, because the answer involves a nerve most people have never heard of, a membrane thinner than a human hair, and a sense so alien that scientists spent decades arguing about how it even worked. Let's start with the organ itself. In pit vipers, rattlesnakes, copperheads, cottonmouths, and in some boas and pythons, there are small openings located between the eye and the nostril, or along the upper lip. These are called pit organs, and at first glance, they just look like extra nostrils. They are not. Nostrils process air. These pits process something far stranger: infrared radiation, the invisible heat energy radiating off every warm object around them. Inside each pit is a membrane so thin, about 15 micrometers, roughly a seventh the width of a human hair, that it can heat up and cool down almost instantly when infrared energy hits it. And that membrane isn't just sensitive, it's suspended in air on the inside of the pit, disconnected from the surrounding tissue, so that heat doesn't leak away or blur the signal. It's essentially a living pinhole camera, except instead of capturing light, it's capturing warmth. Here's where it gets interesting. That membrane is packed with a special protein called TRPA1, the same family of protein humans, used to feel the burn of wasabi or the sting of tear gas. But in snakes, this protein has been repurposed. Instead of triggering pain, it triggers a heat signal that races through the trigeminal nerve, one of the largest nerves in the head, straight to the brain. And this is the detail that stunned researchers. The snake's brain doesn't process this heat information separately from vision. It merges the two. In a region called the optic tectum, infrared signals and visual signals are layered on top of each other, almost like two transparent images stacked into one. The result isn't just feeling warmth. It's closer to seeing a living heat map overlaid directly onto the world in front of them. That means a rattlesnake hunting at midnight isn't groping around blindly. It's watching a glowing outline of a warm-blooded rodent moving through total darkness, with enough resolution to tell the difference between the animal's body and the cooler air around it, and precise enough to guide a strike accurate to within a few degrees, even with its eyes closed. Now here's the twist most people don't expect. This isn't just for hunting. Pit organs also help snakes avoid becoming prey. A pit viper can detect the approaching body heat of a predator, or even sense subtle temperature shifts in the environment that hint at shelter, sun-warmed rocks, or where to escape extreme heat. It's less like a single hunting tool and more like an entirely separate sensory world running in parallel with sight, smell, and touch. So why don't we have this? It's not that heat detection itself is rare. Humans can feel warmth through nerve endings in our skin, but that's a completely different system. Our skin senses heat only on direct contact, over a broad area, with poor precision, and no image-forming ability whatsoever. We can tell a stove is hot. We cannot tell, from across a room, the exact shape of a person standing in the dark. That would require an organ built specifically to isolate, amplify, and spatially map infrared radiation, and nothing in the human body does that. Not our eyes, which detect visible light, not our skin, and not any nerve pathway we possess. The reason is evolutionary pressure. Pit organs evolved independently at least twice, once in pit vipers, once in boas and pythons, because both lineages faced a very specific problem, hunting warm-blooded prey in conditions where regular eyesight fails, like nighttime burrows, dense brush, or total darkness. Mammals, including us, evolved under very different pressures. Our ancestors relied on binocular vision, color perception, and eventually tool use and social cooperation, not remote thermal tracking. Evolution doesn't build senses because they're It builds them only when survival specifically demands them. For humans, it never did. And this is why pit organs remain one of the most studied and most copied senses in nature. Military-grade thermal imaging cameras, night vision technology, and heat-seeking sensors all borrow the same basic principle. A rattlesnake perfected millions of years before humans figured out infrared even existed as a form of light. So the next time you see a snake's face, look again at that small extra hole near its eye. It's not a second nostril. It's not decoration. It's a biological infrared camera, wired directly into the brain, giving these animals a sense so far outside human experience that we didn't just fail to evolve it. We couldn't even fully explain how it worked until modern molecular biology caught up in the last 20 years. Nature didn't just give snakes better eyesight in the dark. It gave them a sense we don't have a word for, because we've never needed one, until we tried to build our own version of it, out of circuits and glass, and called it thermal imaging.